So those are the kind of 4 different transformations we can do, and we can understand that visually as well. There's 2 things that we can also do in terms of its relation to the x and y axis, right? So for example, to reflect in the x-axis, so reflect in the x-axis, so I have a graph like this. Let's say I have y equals to x squared. So there we go, like so. And then if I want to reflect that in the x-axis, so I'm trying to imagine a mirror over here and it just flips that way. Let's do that in a different color, we'll do it in red. That would just be y equals to minus x squared. All right, so what are you doing here? So the idea is the transformation that you're doing is y is equal to minus f of x. And so you can see that's a form of a vertical dilation because k in this situation is -1, right? And we can do the same thing for the y-axis, right? So reflecting the y-axis. Okay, so this time we can do a different one. Let's have a think. We could do, this is y equals to f of x. So if it looks like this, for example, right, to reflect that in the y-axis, so kind of like, yeah, again, getting a mirror and then you can see it on either side reflecting over. So this would be sort of reflected there, and then this guy would come up, like that. There you go. So to do that, we have y equals to f of minus x. So that's a form of horizontal dilation because a is -1 in this situation, okay? So that's 2 other kind of transformations that we can do. Okay. So there's really 3 types of questions they can ask with this. The main one is find the equation of a transformation. So they give you some equation, they ask you to transform it. They can say, okay, let's take this point. What happens to the new point after all these transformations? And the last one is just to describe in words the translations that are happening there. So I'll show you a couple of those examples. So here's the first one. Okay, so f of x squared is translated up 2 units and 3 units to the right. So you can think about this visually. You can just approach it from like using one of these rules, right? Now with the order, unless they say it's specified in this particular order, you assume this order over here. Again, just reminded that 1 and 2 and 3 and 4, they can be swapped around and that won't change the curve. So let's look at a translation up 2 units. Well, actually, let's stick with that order. Let's go 3 units to the right. So I'm thinking 3 units to the right, okay. If I actually want to move it 3 units to the right, b actually has to be a negative value now because that would create f of x is equal to x minus 3 all squared, right? As f of x equals to x minus 3 all squared, that would give you this guy. Okay. So, yep. And then if we shift it up 2 units, then that's a vertical translation. So we add c on the end of that and move it up 2 units. So actually, let's get rid of this axis. So like so now. Okay. So f of x equals the square root of x is horizontally dilated by a scale factor of 1 and 3 and translated down by 5 units. And again, you can just approach these algebraically, right? And remember with the horizontal dilations, this is the scale factor at 1 on A occurs when you multiply the x values by A. So in this situation, because the scale factor is 1 on 3, we'd be multiplying by 3 here. So let's start off with that. So we're going to end up with f of x is equal to, we're going to take x, replace it with 3x, and we're translating it down 5 units. So again, thinking about this over here, we've got minus 5 on the outside of the whole thing. This time we've got horizontal dilation again. Now we've got some vertical and horizontal translations. So f of x equals to x squared. That's going to become now horizontal dilation scale factor of 1 and 5. Remember that means you multiply by 5 here. So that's going to become 5x all squared. So this whole thing is squared now. Now I'm going to do a horizontal translation 2 units to the left. So if I want 2 units to the left, then I'm going to have to add 2. So f of x plus 2. So that's going to become f of x plus 2. Right? So only the x is changing to x plus 2, and that squared stays out the whole thing. And then 6 units down, so that's outside the whole function. And you can simplify that out a bit as 25 x plus 2 all squared minus 6. So I think that's an example of one where the textbook didn't quite get that one right, because we have to make sure that we're changing them according to these expressions. And last one, we're combining them all together. Here's our original, f of x equals to ln of x. Now notice how they give you the order in the verticals and the horizontals. That actually doesn't matter, you can try it both ways, and as long as you do the dilations before the translations, you should get the same answer. Let's try the vertical one. So dilation factor of 8, that would become 8 ln of x. Translation up by 3, so that's going to be plus 3 over here on the outside. Horizontal dilation of 2, so factor of 2, just be careful. Usually you've got 1 on A, but in this situation, right, you're given a whole number. So if the scale factor is a whole number, this now is going to become the reciprocal. Because think about this, what value of A here does it need to be for the scale factor to be 2? Because if you just put 2 here, that's going to be a scale factor of half. So A actually has to be a half over here, which means when you come back to this, the value that I'm going to multiply by is actually half x. So it's going to become half x here now. And then 3 units to the right, so remember that's going to be x minus 3. Okay? So that's what that should look like.